denominator is one term, so 1/4 minus cosine squared to x divided by 4. As you know, this is the same thing with 1/4 times cosine squared to x. And you can say, what did you accomplish? You still have powers. True. I want no powers. It can have any argument inside cosine, but no powers. Excellent. So now I want to replace this by what it equals to. What does this equal to? It's the same formula. So when I had x, I had 2x. For cosine, I had x, I had 2x. But now I have 2x. So what should I have here? And this is not multiplication or anything. This is an identity. So if this is cosine 2x, then the formula will be 1 plus cosine of over 2. Of what? So let me write the formula one more time. So cosine squared alpha equals 1 plus cosine twice alpha over 2. This is the formula we are using now. So when I have 2x here, what should I have here? 2x. 2x, what should I have here? Anyone, please give it a shot. Please, anyone?
Will it be 4?
Exactly. 4x indeed. Good. So we continue. 1/4 is 1/4. Negative 1/4 times 2. So this is going to be this time over 8. I have 1/4 times this over 2. 4 times 2 is 8. And the numerator has 1 plus cosine 4x. There's nothing else we need to do here, but I would like to separate it because I can combine 1/4 with negative 1/8. So I'll continue with the... Yes, please stop me. Any
I have a question.
Yes.
Where did you get the other 1/4 from?
This one here?
No, on the left.
This one here?
No, down on 1/4 minus 1/4.
Okay, so I started here. 1 over 4 minus 1 over 4. So I separated this fraction into two pieces, into two fractions, 1 over 4 and this over 4. But I was explaining that this is the same with 1 over 4 times cosine squared.
I see it now.
Perfect. And then we replace this by 1 plus cosine 4x over 2. So I copied 1/4. Minus 1 over 4 times 1 over 2 becomes 8 in the denominator. And I have to copy the numerator. So 1 over 4 times this over 2 is this at the top. 4 times 2 is 8. So now we have 1 over 4 in front minus 1 over 8 minus 1 over 8 cosine 4x. 1 over 4 is in front, minus 1 over 8. I separate this fraction now into two pieces. Minus 1 over 8 minus cosine 4x over 8, or minus 1 over 8 cosine 4x. I had to do this because I have to combine these two. So the least common denominator is 8, so I have to multiply the top by 2. So 2 minus 1 is 1. So this is 1 over 8 minus 1 over 8 cosine 4x. No powers, as I promised. We started with sine squared times cosine squared. Both of them have had powers. And slowly but surely, we got to an expression with no powers. Any questions? Now feel free to choose another if you'd like. I only have one on the handout, but we can choose another if you'd like to. There must be more somewhere. This was problem 36. 36? Which page am I on? 549. I'm on 549. Yes. Okay, so yes, so this is an example here, 43. Yeah, I think that this problem was recommended from a different book because this book didn't have enough. Because I can see other examples. Yeah, I think it was recommended from another book. But we can do this one, the cosine to the 10 cosine to the 4th. Yeah, let's do that. So we did the first one, which was my invention, so to speak. So let's look at cosine to the 4th x. So we want to know powers. Okay. I don't have a formula for cosine to the 4th, but I do have a formula for cosine squared, which is 1 plus cosine twice x over 2. I do have this formula. So therefore, I will break cosine to the 4th into cosine squared squared. Do you agree with this step? Is cosine squared squared the same thing with cosine to the 4th? If it is, I can proceed. If it isn't, then I cannot continue. Is it the same? Are these the same?
No.
Why do you think no?
Oh, I just thought because whenever you have a power, you're supposed to apply it to everything that's within the parentheses. So wouldn't it also square the x that's or the article? that
Okay.
goes on?
So we can never touch the argument. So when I multiply sine x by sine x, I do not get sine squared x squared. Because this is basically the same thing to with sine x squared. I am squaring the function, not the argument. So when I have f of x everything squared, I have f of x squared. I don't have f squared of x squared. So again, no one can touch the argument. When I multiply a function by the same function, f times f, I get f squared. But no one can touch the argument inside x. So sine squared is just sine times sine, which is sine squared x.
Okay.
So therefore, we copy the base and multiply the exponents. So cosine squared x squared is cosine to the 4th x. No one can touch the argument inside of a function. Okay, and I have a formula for this, or an identity. Here it is. So I'm going to replace all this by that. 1 plus cosine 2x divided by 2, everything squared. I will square the easy part, which is the denominator. Can anyone square the difficult part, which is the numerator? Please square the numerator. And tell me how many terms will you give?
I have a question, sorry.
Yes, yes, please, please.
The formula, the cosine square x, from what subject is that from? From what is it from the last one, the one that we're doing right now?
Yes. Yes. So You want me to go back and explain where this is coming from? I'll be more than happy to do so.
Sure.
Yes.
Yeah,
Okay.
appreciate it.
Sure, of course. So let's keep this aside and let's go back and talk about that. So remember last time we had cosine twice x as 1 minus 2 sine squared x, or cosine 2x is 2 cosine squared x plus 1. Do we remember these two?
Yes.
Remember, they come from cosine 2x being cosine squared x minus sine squared x. And we developed these two from here, from x plus x. Okay. Now, I am going to solve this equation for sine squared, and then I'm going to solve this equation for cosine squared. That's where these formulas are coming from. So let's start with this one, because this is what we're talking about right now. I subtract 1, cosine 2x minus 1 equals 2 cosine squared x, and now I divide both sides by 2. So then cosine squared x equals, because I wrote plus. That's why. So I have 1 plus cosine 2x over 2. So from this identity, I solve for cosine squared. I add 1, so I have cosine 2x plus 1, or 1 plus cosine 2x. And I divide both sides by 2, and I get this identity. Cosine squared x equals 1 plus cosine 2x over 2. Now the other identity comes obviously from here. I will subtract 1. Cosine 2x minus 1 equals negative 2 sine squared x. I will divide both sides. I will first multiply both sides by negative 1 to make it nice and neat, and this it should be. 2 sine squared x equals 1 minus cosine 2x. And then I divide by 2, and I get sine squared x equals 1 minus cosine 2x over 2. These are two very important identities, this one and this one. And they are identical if you want to remember them like this as a pair. But this one has plus for cosine squared, and this one has minus for sine squared. And everything else is the same. So if I go back to this example that I made up at the beginning, sine squared plus cosine squared, I replace sine squared by this. I replace cosine squared by this. And these are the formulas that we just redeveloped here. 1 minus cosine 2x over 2. 1 plus cosine 2x over 2. So these are very important. And that's how we started. And we multiplied, and we multiplied, and we simplified, and we replaced this one also using the same identity. So now remember what we said. So if this is 2x, then this has to be 4x. If this is 7x, then this has to be 14x, and so on and so forth. And they work for any angle, as long as this one is double of this. So that's why when we had 2 here, actually for a cosine, when we had 2 here, we ended up with 4 here a few minutes ago. Is this better? Do we feel a little bit better now about these two identities?
Yes, thank you.
Excellent.
I just didn't have those two identities
Yes.
on my notebook. That's why.
Yes. So it was last time. So this is the formula from last time. You can memorize it or remember it if you want as alpha over 2 equals alpha, or you can memorize it as alpha equals 2 alpha, and that's where they were coming from. from last time. Let me see, I just want to make sure I didn't merge last time's notes with today's notes and I scanned them again. Okay, so where are we? We're here. So can anyone now square this for us so I can put it up here? Can anyone square this for us so I can put it up here?
1 plus
Yes?
2 cosine 2x plus cosine squared 2x.
Excellent. Thank you so much. Thank you. I'll separate it again into 3 fractions now. 1/4. 2/4, which is 1/2 cosine 2x, plus 1/4 cosine squared 2x. This is nice, no powers. Ah, but I still have a power here. I don't want powers. So what should I replace this by? What do I replace cosine squared of twice x by? Look at this formula and you will know exactly what to say. Anyone, please? The identity is up here, but now the angle is 2x. Give it a shot, please.
1 plus cosine 4x
Excellent. Over.
2.
Excellent. Thank you for saving us. This is it. So 1/4 plus 1/2 cosine 2x. 1/4 times 2 is 1/8. And now I split it again. Plus 1/8 plus 1/8 cosine 4x. And yes, I have to add these two. And it's done. You cannot combine this with this. They're different functions, different arguments. So 1/4 plus 1/8, I need a 2 here, so it's 3/8. And that's final. So look for the triangle. And this is page 9. So 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. Done. And we started with something quite ugly. Cosine to the 4th. And we got something very simple, no powers. Power 1, power 1. Good. Any questions? Any questions? Any questions for me, please? Anything? Okay, I'm going to choose a simple one for you to work on for 2 minutes. Number 10. We have cosine theta equals 3/5, the easiest example possible. Theta in the first quadrant, and let's say, is there one that we haven't looked at? Let's say cosine theta over 2.
Sorry, can you repeat the ones that we're doing?
Cosine theta equals 3/5. Theta is in the first quadrant, and you're asked to find cosine theta over 2.